Okay, and I think we are live. Um, hey everybody, I'm gonna give it a couple minutes just for folks to drop into the stream. Is why is while I collect my wits about me. Um, as we just switched to a new platform for hosting streams. We're using StreamYard now. I'm still getting used to the controls, so we should be getting officially started in just a couple minutes. Okay, I'm gonna say we're officially back and ready to get going. Um, yeah, so let's jump into it. Uh, hey everybody, thank you for coming out to Typescript Tuesdays. Um, my name's Kirk. I am one of the maintainers of Virtual Coffee. For those who might be watching this online or on YouTube or not on the live stream, Virtual Coffee is an online tech community that's trying to be a space for learning and leadership at all levels, trying to be a welcoming space. We have a bunch of initiatives, and one of those is the stream started up with one of the other maintainers, Dan Ott, called Typescript Tuesdays, where every 2 weeks we just kind of take a deep dive into TypeScript, different aspects of using TypeScript in JS environments, using TypeScript on its own, type-driven development, functional programming, object-oriented programming, whatever it may be. And we try and do it in a way that's informative and accessible and available for everyone watching. So yeah, with that, we can kind of talk about what we're getting into today. Originally, I planned on doing some work or showing some work on working on some of our Slack features. But that is actually quite difficult. Um, there's a few issues that I'm having, not really sort of like anything beyond the norm, but it's going to be difficult to like show this aspect of the project, which is mainly me doing a lot of reading and Googling and researching. I don't know if people are particularly interested in that. So I figured what I would instead do is show off some work I've been doing with TypeScript with some scripting. Um, I've been using TypeScript for scripting for the last couple months or so. That's been really fun for me, super valuable. It's a practical application of TypeScript that I really enjoy. It's also a space where we're using TypeScript without necessarily being involved in like the browser, which is a thing I know a lot of people aren't familiar with. It's like when you think TypeScript, when you think JavaScript, you're like automatically assuming that you're doing some work with the browser, working with the DOM, working with like HTML nodes, but that's really not the case, right? The whole point of this all is that like with access to things like Node.js or Deno.js, like we have these like run times for JavaScript that exist on your native machine on your operating system, which means you can execute code in a non-browser environment, right? Like the only thing about the browsers, all browsers have a runtime that can execute JavaScript. If you make something else that can execute JavaScript, then you can stick it wherever you want. So I've been taking advantage of that. I've been using that to sort of do some scripting work for myself. I'm going to maybe show off some of that and kind of talk through what's going on, what my methodology is, what I'm hoping to accomplish with it, and sort of how I'm going about it. And yeah, we can just kind of jump in there. Um, Also, I do need to double check that the stream is accessible right now. And I'll drop a link in the Slack so folks can come out and check it out if they would like to. And I think once we do that, then we can say we are officially started. Okay, so that's working. Cool. So let me do a screen share. And let's see if we can grab what we want. Okay, screen share is like, StreamYard is like, hey, you want to share a tab? Okay, don't want to share a tab. It's like, hey, do you want to share a window? Okay, not particularly. So we're probably just going to have to try and share our entire screen again, which I'm not super fond of, but we can make it work for this. Just got to do a couple adjustments. That should work out. This is also a painful reminder of all the tabs that I have open, which is far more than I need to. And, you know, I'll deal with that whenever, but not now. Let's get a couple more things. So let's see. To get my right VS Code window. Actually, that's giving some trouble. I'm going to try and screen share again. Maybe that would be better. Okay, we'll have to wing it. We'll see if we can make it work. Okay. And I think we got there. Okay, so what are we looking at? This is this sort of like core repo that I use for basically everything. Is kind of like my little home base after, I don't know, 25 odd years of starting and stopping to use various like organization apps. I was just like, let me just do it myself. And what if I just kept everything in a GitHub repository, right? And the version control is like fine. I have VS Code for expressing whatever I need to express. This is part of a theme of kind of like build your own tools. So it's like, hey, there's this thing I want. What if I just made it myself? I'm more likely to use it because I made it myself. I'm also more likely to have it do exactly what I want it to do because I made it myself. So that's what we're doing here. And you know, most of this is various markdown files just for my notes. You notice kind of a funny naming scheme here. These the folders are all named after places. My favorite book series, Discworld series. If you're looking for just great books, you should check those out. They're my favorite. But particularly in this folder is where I keep like a bunch of scripts that I've been testing out for doing new things. So you see ones here like create new day and create new week. These are ones I've been using to sort of like generate templates for just like getting going. And so it's like, hey, when I start a new day, like I always want like a little tab for book bookmarks, a little tab for tasks, and like a markdown file, like for appropriate headers. So instead of like rewriting that every single time, I'm like, hey, let's just make a template and then let's just write a script that does it. And we can talk a little bit about how it all works, because I feel like that's pretty neat. The key things here about like this entire project is that, like, you'll notice, unlike most JavaScript and TypeScript projects, you see there's no JS here. There's also no like public or like dist file. Like there's no output file of any kind, because I don't really need any output files. Like all these things are doing, they're just like scripts that are being like executed in the shell, and then the output is usually a creation of a file for another one of these projects. So like there's no, I'm not like passing the code off to something else that has to use it, which is how you think of like a normal like JS application. Like, oh, I write some TypeScript, it gets converted to JS, it gets used by a browser or something like that. But in this case, that's not the case. The pipeline is, I write this TypeScript straight up. I use a package called, I'll show it to you here. I use it goes like straight into Node. And I use this TS Node package, which basically lets me, like, instead of having to convert first to JavaScript and then feed that into the Node engine, I can just send it to TS Node and it does the conversion for me, and it pipes that into the Node engine. So I don't need to interact with like raw JavaScript at all. It's just all TypeScript, goes to Node, Node runs the code, and then we kind of like move on from there. And that's really great for me. That's like exactly what I'm looking for. And what that means is, like in my TS config file here, you'll notice one of the things is I don't have like any reference. Usually when you look into a TS config, you'll see like references to like the DOM library of types or things like that. Like we don't have any of that because we don't need to. Like the only library we're using is like the latest version, like the 2021 ECMAScript standards. Allow.js is false. I do not want any JS here because I will never need it. So I don't want to see it. I don't want to have to use it. No emit is true. So we're telling it like, hey, I never want you to attempt to pipe any sort of output because we don't want any sort of output. And then our sort of like normal TS config values, And then here we have this little note in TS node, transpile only. That's basically us saying like TS node has the ability to type check your TypeScript for you, that we're already using the type checker that like ships with VS Code. Like we don't need both of them running. So this is just like a speed hack. Like there's no point to this. It's like, it would be like a double compilation, but we've already done our compilation, so we don't even have the compilation. So like, hey, I just want you to change it to JS. Don't check if it's like good or not. I've already got that. And that's pretty much the setup. And it works really well. I'm kind of like super happy about it. And then just to kind of show how we're using it and how we're sort of integrating it with VS Code, which I think is like the most important part. VS Code has a concept of tasks, right? So if we do like Control-Shift-P, I don't know if you can see that drop down. Folks should tell me if you can see that drop down. But VS Code has a command palette, and then in that command palette, there's a bunch of like task things that you can do: run task, configure task, build tasks. So we're basically using this code and plugging them into custom tasks for us that we can then like ask VS Code to do. And that feels really good. So just to kind of show maybe how we set that up as well. If I go down to a little code workspace here, we don't need to go here. We see like we have a little task set up. So it's like, it's a shell task, and we have a label for it, which is like creating a new week, which is basically creating a markdown file set up to like put in all the tasks I have for the week. We can pass in commands, so it's going to be an npx command, so we use a node environment. We can pass in the argument, so it's npx ts node run script.ts, which we can find like in our like files here. and then we can pass in like some arguments as well. So basically, like this is what we would have typed into the command line ourselves, but we can just feed it in here. We have like some optional stuff to grab the right workspace folder, and then like we can even set like the inputs we want from the prompts, so you can get like the normal VS Code drop-down prompts, and it's like a nice little, at least for me, like it works as a nice little automated system. So I just have these custom tasks for different things that I want to do. Although I've been doing some like heavy refactoring, so I got rid of some of them as I'm gonna like move to a different system. But yeah, you know, the pipeline is TypeScript code being fed directly into the Node engine without having to use the intermediate step of JavaScript in between, and then VS Code to set up task prompts from the VS Code interface to run the appropriate scripts. And that's what I've been working with for a while, and it's been pretty good. And yeah, so how are we going to use that? I'll stop sharing for a little bit just because it's hard to see chat and also share at the same time. We can jump back in. Okay, so what we're going to be trying to do today is we have a new script that I'm trying to make, which is doing a bunch of setup for some job application stuff. It's like whenever I make a new or try and do a new job application, I want to make a folder for the company. I want to get some like data on them in there, like whatever their supporting materials is. I want to create a cover letter file so I can write a good cover letter, like all these things. And every time I do that, I have to do all these things sort of like from scratch. So it's like, hey, this is probably a good space to try and automate this and just turn this into a script. Just have the thing run, collect a bunch of info, and kind of have it go from there. And I've kind of started the process of working through that, and we can kind of walk through what I've got so far. Mind you, you'll see this red here because I introduced a couple breaking changes as I realized a better pattern for how I wanted these to work. So at the core of everything, I have this run script file, and this is actually what my tasks, my task definition in VS Code calls every time. It always calls run script, and run script has a job of like accepting the arguments that are being passed through the process, getting the correct name for what script I want to run, making sure that like that name exists, and then like calling the appropriate thing. So just to kind of like see what's happening here, like we import our scripts up here. We add them to this object containing all the scripts you want to run. So right now I just have create new job application as I'm working with the new one, but create new week, create like daily update, like all the scripts are going to be added here. We can use some TypeScript inference to get the names of everything that we add to this object, which is really cool. Here we're using some node functions to basically grab all the arguments that are passed into the process. So this is how whatever we say is necessary from externally for the script, we can just get them right here, which is really cool. And then here we're basically saying, hey, if you got a current working directory, and if the current working directory is real, so like bad values won't pass muster, and if you got a valid script name, like if it was truly a script name is passed, and probably most importantly, it is part of the existing scripts that we say are able to be used here, then hey, run the current script essentially. But if any of that isn't true, or if like any of this like fails or throws an error, we catch it, we log it out, and we sort of like shut down from there. So like by the time we get to the script, we've done like some core validation here that hey, like the directory we're looking to do this in and the script we're using to run, like those are all real and like no shenanigans happen there. And this is really good, right? This is sort of like our safeguard against fumble fingering something, or if this process fails for some reason, it doesn't get the arguments, like we don't get, you know, 2 or 3 layers deep into actual like process code, only to realize, oh, this is bad, we shouldn't have done any of this, you know. So it's like, hey, if everything seems above board here, you're good to go. If not, then, you know, stop and tell me what's wrong. And it isn't perfect. There's a couple of things I do want to add to this, like, you know, like being able to have like more expressive errors for these things. Some of these things like won't necessarily trigger an error, but it's worth like passing it and like doing some messaging. So, you know, adding logging to this is on my list of goals, and it's definitely something we're going to think about. But for now, you know, this is where we're at, and this is pretty stable. Um, so now to kind of jump into maybe one of the old ones that we had. So like the old one we were using here from is create new week. We can check out create new week. We have like a little test file here. You can see it on this side. So we have some tests that we wrote for it just to make sure our code works, because we like to practice, or I like to practice, unit tests and integration tests whenever I can. So I'm really happy about this. We have sort of an index where we sort of provide access. This is where we get to say, like, this is, you know, like, oh, the real thing we want to export is just this little object of create new week, and access to the run method, which is how this whole process gets started. And then create new week, that's really where the magic happens, right? Basically, when we run, we get the command, the working directory, and then for this create new week, the big thing it needs is a date range to decide like how it's going to generate the markdown. So we have a date range. We're doing some like basic logging just to inform whoever's running this, like, hey, this thing has started. We have some validation logic. Hey, does this make sense as a date? What happens if it's wrong? Can we do some defaults? What's the valid start? What's the valid end? End has to be past the start. You have a function here, create markdown, which is just like the basics for getting this template set up. It basically uses a date range to generate the right markdown tags for the different headers. And then finally, we attempt to write the file to the appropriate directory, you know, and we do some error handling here in case it doesn't work. And, you know, like that's pretty much it. And that's all that's happening there, right? So the whole setup is small scripts doing some basic either code gen or text gen, and just hooking into VS Code. So like in my actual usage, I don't need to open up the command line. I don't have to be like typing like raw text or like making sure I get commands right. I can just use the regular VS Code prompts and kind of follow them, and it kind of works out. Yeah, that's pretty much it. But with this new one of create Java application, I realized there were a couple patterns here that weren't necessarily, they're fine, but they don't scale particularly well. So in addition to making this new project, I also want to change the way these things work in general to make them a little more robust and sort of like easier to like build as an interface. You know, like there's some patterns that I want to pull out and make them more usable. And a big one is, and maybe sort of like the theme of today, or the thing I want to talk about, is this Zod library. And I will stop sharing the code for a while, so I would jump to the website and talk a little bit more about Zod. So I'm pretty excited about it. What is Zod? For many of you, you might be familiar with Zod as that dude who hates Superman. One of the dudes who hates Superman. Lots of people hate Superman, for good reason. But in our case, let's see if I can pull up the actual website for you. Okay, we're going to avoid the infinite of doom. Yeah, so Zod is what we call like a schema validator, or, you know, a parser is another way to think about it, which is just a fancy way of saying Zod checks to see if inputs match some standard that you've defined, right? The most, I mean, the usual use case is you have some external data coming in from somewhere. It could be an HTTP request, like it could be like, over there. It could be some file IO. You have some stuff coming in, and you want to be sure the stuff coming in is what you expect. And like you want to be sure the stuff coming in is matching some specification that you have before proceeding with the rest of your code. So rather than sort of like doing what I've been doing, and as you saw in that other file, sort of like doing a bunch of like bespoke, hey, it's like, is this a date? Is this a string that I want? Yada, yada, yada. Zod provides like a really nice interface for doing that for me. Also, probably the magic of Zod, and what I love about Zod, and maybe like the most impressive thing about it compared to like regular parsers, is it's really easy to go from Zod to TypeScript types. The types are what I really want, right? Like the types help my code ensure that like it's working in an environment that makes sense and like all my operations are logical. And then Zod sort of ensures that the data coming in matches the domain that I've represented, and then like all that's logical. And what Zod lets you do is it lets you sort of make these schema parsers that do both of those things at one time. So I can make a parser that makes sure my code is what I want, and then generate a type from that parser. So once I've defined the parser, I've also sort of like defined the data structure that I need, and that's super powerful. Yeah, Zod's great. A lot of people use it. It's got a bunch of integrations for React, for Svelte, for Remix, for Nest, Jest, Fast Check, Prisma, all the JavaScript words, because the JavaScript environment has a million words. There's even TS to Zod, which lets you turn TypeScript definitions and Zod schemas, which is kind of amazing and something I want to poke around with because I kind of like that as like being a more powerful source of truth. I'm really tempted to open this link right now, but I'm not. I'm going to click it and open a new tab, and I'm already in here. I don't know, this seems very interesting to me. Okay, looking at the interface, I don't know if it's exactly what I thought it would be, but it still looks cool. But yeah, but instead of doing our bespoke parsing from before, we're going to try and use Zod instead to do that. And that should be really powerful, also just more consistent. The Zod team have like spent much more time than me thinking about edge cases and interactions. And so that's going to be something I think is really cool. Oh, you're seeing me like doing the infinite zoom again. So let's jump back to the code and let me show you sort of like what things I'm already using from the Zod library and kind of like where I plan on going from there. So let's share screen again. This time we're going to go entire screen. I'm going to come here. So, this is my first attempt at using Zod for this project, and kind of walking through thinking of what do I want from this Zod application. So one of the things I haven't talked about, or one of the things I do is like every time I apply for a job or a company or anything like that, I have a tracker where I just keep some basic data about the company just for my records later. So things I want to know is like, what's the name of the company? What's the position that's being offered? What date did I do the application? What's the company's like home base? These types of things. So all of this is stuff that I want to just be able to pass into the VS Code task runner just through like a series of prompts. And then all this is what I want to be collected and then passed into my eventual application. So what Zod lets me do is it lets me make like these little sort of like small parsers, and then I can compose them into a big parser, right? So ultimately, these things are going to come in as just a array of arguments, just a straight up array of arguments. So we want to kind of like grab that array and kind of work from there. So here we're sort of saying, hey, what I want, I'm giving me like a tuple, like a tuple, just like a sequence of values. And then we're going through each one, or just deciding like what we want it to be. The nice thing is we don't have to define it like all in one place. We can separate them out into their own separate functions, because these are really just functions. So like for our current working directory, I can say, hey, I want a non-empty, for my current working directory, it needs to be a non-empty string. So like here I have like c.string, which like just parses a string. And then there's this refine method that like lets you pass an additional parameter to the parser. So not only is it a string, but it has to be a string whose length is greater than 0. As I look at this, I realize that one of the things I want from this is one of the things I had in my create new week. Actually, in my run script parser here, I have this exist sync method that just calls true if the path exists. So I actually want to do exactly that again. And it's funny that I didn't think about it when I was writing it, but now I see it. So I want to say, instead of doing this like s.length greater than 0, which is true, I think what I want to do for this one is actually make a const CWD schema. And yeah, that's kind of how we want to go here. But you see what we're kind of doing here. Like we're saying, we're defining a schema just for one line in the tuple, and then we're adding it to like the tuple schemas, and like it'll understand the whole thing. So here we're saying, hey, it's got to be a string, and it's got to like exist in the file path itself. And then here, I think I'm going to say, I'm just going to change this for a CWD schema. Yeah, so I've got one for a non-empty string, because company name, I don't know what the company name will be. I just, like at the very minimum, it needs to be a non-empty string, just so if someone accidentally doesn't enter anything, then like that's captured in the parser versus figuring that out later down the line. Because like, to be honest, if I don't know the company name, then none of this really makes sense. So it's like, it's got to be something. Here we've got a parser that does something really interesting, where we can transform our inputs. So we're getting a string, and then here we're like changing it into like a string or null, because even though the stuff from the command line arguments might be just like empty strings, I want to change it. Whenever I see an empty string, I don't want it to still be a string. I want it to be like a null or undefined. So this is what this does. Basically, was there a string, and then transforming it into string or undefined. Here we have one for dates, and we're doing some date coercion. So they're going to pass in a string. We're going to convert that to a date. We have a default value in case it doesn't work, or we just use whatever the current date is. So you can do defaults and Zod. Our country schema, for now, we're working with the US and Canada, so we get to use literals here, and that's really powerful. So we can just say like, hey, it's got to be either this one or this one. And then here we've got the easy apply, where we're basically transforming from a string again to a Boolean. So put them all together. And the last thing we do, maybe like the most amazing thing I think we do, is we can transform all of this. So at the beginning, yeah, we're getting a tuple of values, but tuples aren't fun. Like tuples are great if you've got like 2 or 3 things in them, but once you get past that, they become like really unwieldy. It's hard to work with them. You sort of have to remember the order of things. It's not very intuitive or ergonomic. Like passing around large tuples is like, in my opinion, like bad DevX. Like it just increases the likelihood of making mistakes and adding errors. And the common convention is, if you have a data structure, a sequence of data where there is uniqueness at different indexes, instead of using a container like an array, you prefer a container like an object, right? Where you just want to have like each one of those things be accessible by like a namespace instead of an index space, or instead of having to do like this sort of like spread operation. So that's what we're doing here, transform. After we get all this, we're just transforming it into an object, right, with these things. And the great part is, all I need to say at the end is like, use Zod's infer method and pass this in as a schema. And I get this type input, and input has sort of like everything I want. Input's got like all the types that I need. And it's kind of annoying because it's not showing you the types. But it's like basically input is now a record with company name, position, date, country, easy apply, support materials, notes. Like that's what input is. And that's great, honestly, because now in the rest of my code, in my actual working code, instead of having to deal with the data that was coming in, which was like potentially all of these things, right? Like the type thrown back from this process.argv is the string array, is what it says, but every value in it is actually like string or undefined. So like the raw stuff that comes out of this is like an array of like string or undefined, which doesn't help me at all and like doesn't give me any insights. But after it passes through my like schema validation, it's going to be this object of exactly the things I want and nothing that I don't, and that's going to be pretty amazing. So here I've sort of started the basis of looking at that. So like we get an input here, and we can do input.company name, and that works because we've transformed this into an object. We can say input.position, and we know that works. Here, input.date, and we know, like, it understands like, oh, this is a date type, not a string to represent a date, but a date type because our schema transformed it into a date. Yeah, and that's super powerful. And then here, where we're gonna like the one part of this we exposed, the run, it understands, yeah, I'm getting an array of like raw string or undefined data. I'm going to do a safe parse on this using our input schema. If it successfully parsed it, then we can just pass the resulting data fully processed, and we can work from there. And if it didn't, then then it got an error in the parsing, and we're gonna log that error message. And that's like the basic pattern, and it's great. Like it's exactly the thing that we want for now, and it feels really good. But what I really like is just like this portion right here, this ability to succinctly and sort of like programmatically define these like small parsers, just like, and combine them into this thing that represents, this is exactly what I need for the data coming in, and this is exactly the way I want to come it out. And if I wanted to do like fancier transformations here, I could. That's totally possible. Like if I wanted to drop fields or add fields or do more complex validation, that's like all perfectly fine. Like once I'm done and I have the shape that I want, I can say like, hey, this is the type. And for the rest of my application, this is the type. We're going to use that, and like we know it works, right? Because like it's got to make it through the parser in the first place. And if it doesn't make it through the parser, then we're handling that. That's the magic of this safe parse. So all these schemas have a parse option and a safe parse option. The parse option, if the parser fails, it throws an error, and you have to like handle that in like a try catch or something like that. I have a soapbox about try catch and how I feel about try catch. The TLDR being that people use try catch way more than they should. And in places where they use try catch, like especially internally in code, you should probably be using a sort of like safe operation, or instead of transforming something from like, hey, the thing you want or an error, it changes it to what we call like a result type, like something that has like a left and a right side. The right side is the success side with some data payload, and the left side is the failure side with an error message. But it's like a data type that you can work with, like you can thread, you can process, you can parse out. So I always opt, whenever I have an option for doing like a regular method or the safe method, it's going to give me something like this. I use a safe method, and I just use, I use like a proper block to handle it, because this is just part of my code now. If I want to do something else with this error message, I could here. I could transform this into another value. I could do something, like this way is much more flexible. This way, the error is not outside the logic of my code. It's just another branch in the logic of my code, and I can like do with it what I could do with anything else. once your code normally hits like an error state and like a try catch block, you sort of like you've ejected out of your code's normal functioning, and you're out of there until you sort of like opt back in. So long story short, I really like this pattern. And I would recommend something like this to everyone. It doesn't have to be using exactly Zod, although I think Zod is great. And I think if you're using TypeScript, there's a really good case to be made for using Zod for validating your inputs. But just generally, from the get-go, make a parser that's going to take the raw data that's coming in and change it into the data structure that you want, and then have all your actual domain logic just work with that data structure, not the raw stuff. You shouldn't care about the raw stuff. You shouldn't even really know what the raw stuff is, kind of getting back to like the principles of like object-oriented design, like making interfaces. This schema is the only thing that should be interacting with that raw data, and everything past this should only be getting this like nice, oh, there we go. Finally, my IntelliSense is doing what it should. This nice, well-to-do, properly structured data type. And yeah, I think that's the way to go. Stopping again just to do a double check and make sure that everything is good. Okay, I've managed to speak for over 40 minutes without pause. So let's see if we can actually write some stuff right now, or at least like talk about the stuff we're gonna write. The more I get into these, the more I feel like actually writing code on stream is odd, because at least for me, the way I write code is very like chaotic. It's very like start stop, with a lot of pausing and a lot of like checking up on things. So it's almost like if I am writing code on screen, I almost kind of need to fake it, like I need to have written it before and then sort of like gradually add it in, which is fine, something we can do if people want. But generally, I feel like showing existing code and talking about like why it exists can sometimes be like a more powerful thing than actively watching someone writing code, because that process just is slow. The only caveat being if there's two people and it's like a paired programming session, then I do think it's useful to watch like the two people talk about what they're doing and then do it at the same time, and then that can be like super useful. Yeah, so let's do one last presentation here. Share screen one more time, and let's see if we can just add a little bit of logic to this, or at least kind of like walk through the type of logic I am thinking to add. So what have we got here so far? We've got our schema for parsing the inputs. We've got our type that represents that parsed input, like our actual type that we're using in the application. And then we have this like run that we're exposing that like gets it in, calls the schema, and that passes it to process, which is where we've been doing the heavy lifting of like all the code we want to do. So I think we can just sort of walk through parts of it. The first step, like we want to create an application folder based on the company name and the current working directory. And the nice thing here is that like we've done some validation. We know that this is like a real string, and we know that this is a real functioning working directory. So let's kind of like get into some folder creation, I guess. I don't know, how do we make a folder? Is a pretty good question, which is something I'm probably just going to try and like Google the answer. Yes, create folder. If it doesn't exist, which is important. And yeah, we're using Node.js. We're asking like, hey, how to do this using Node.js. And I'm going to do a thing here, which I always recommend to people to do. We've hit the point where certain aspects in software have been around for a long time. And I don't know about anybody else, but I frequently run into this problem where I'm doing a search for something code related, and the most popular answer, the first couple of answers, were from, yeah, I would say like 5 to 10 years ago. It doesn't mean those answers are bad, but a lot of times you go to the answer and it's like, oh, this answer is based on what the solutions were like at that time, and we've moved forward and things have either gotten easier, or there's been a change in the syntax, or there's just like a new method to do it. Um, and then you have to like check all over again. So I always like to include this little after, and I just like put after a certain time. Recently, I've been using 2020. It doesn't really matter. You don't want to use like too soon, because if you say 2023, like if no one's written about what you're looking for in like the last 5 months, you don't get anything. But I usually like to give it like 3 or 4 years. So at this point, 2020, 2019, even like 2018 can work if you're like looking for like ES6 stuff, just to make sure that the things I get are probably still relevant. So now I get a different first one, which is not a Stack Overflow from 9 years ago, but this one. So it's like, hey, we've got a exist sync to check if the directory exists. And then here we have the make directory function to asynchronously create a directory. Got a directory name and a callback. And then there's a sync one to synchronously make a directory, which might be what we're doing. We're not necessarily trying to do the async version yet. Like I'm fine with having these like execute in particular order, because if for some reason it can't make the directory, nothing should really continue. So that's kind of important. It should be a blocking operation. Oh yeah, and like all of this is using the FS module, which just stands for file system. So that's kind of like what we're working on. So you've got write file, create a file, and writes contents into it. That sounds really good. We have an append file, add more content to an existing file. We have a read file, makes a directory and renames a file, and all that sounds great, actually. So let's see. Looking at the way this API works, I feel like, and there's a conversation here about like what's our best order of operations. Initially, I was thinking, hey, let's make the folder, then let's put a file in it, then let's put another file in it, then let's, like in that path, like making the folder first, wrapping that up, and then going from there. But it could make sense to kind of have that all ready to go at once, like just when we make the folder, also pass the like have the contents ready to go. So like open it up, put the stuff in, and then sort of like wrap it up, and then like we do all that in one sort of like one clump of I/O operations instead of having 3 or 4 successive trips to and back from the system. So that could be super valuable. And yeah, this is like part and parcel of like working on things, right? And like deciding on APIs and code structures. You do some reading and you think about what is going to be the best possible path. So I'll just kind of like finish up with this article. Recursive create directory if it doesn't exist. That's interesting. I'm always a little spooked whenever I see recursive methods mentioned in like a JS environment. Not sure you can't do it, but you just have to be a little extra careful. There is like a hard limit on the amount of like recursive things you can do in JavaScript. Like you'll never hit it for like a directory structure, most likely, but just something to be careful of. But yeah, I think what we want to do is something like this. So if we want to jump back to our code, in here, we're gonna do something like fs, nope, not fs that, but fs dot, and it would also help if I got the directory out there. I guess make clear is the async one. Let's see, expected 2 to 3 arguments, but got 1. What do we need? A path. Directory options, recursive true, and a callback, which is interesting. Callback is given an exception, and if recursive is true first, okay, so the undefined, created, make clear, recursive is true, error, interesting. I think what we want right now, I don't want recursive to be true. I think I want recursive to be false, at least for now. I just don't particularly trust that. And for the error, we just watch. For now, let's just like log the error. That feels like the safest way to go. Right, so something like this, we're going to make a working directory with our company name, graciously provided here. We don't want to do any recursion, and then just like log out the error, and that'll be really cool. Now I realize what I really want from this is I want some extra step here. I want sort of like, do I need an external set of contents? So what else from here do we need to kind of like make the contents? The main thing is these like support materials. So I always like to make a file that has like whatever support materials for whatever application I'm working on, job descriptions, extra notes about the company. So we'll keep our support materials. Support will be a string. A lot of you might be saying maybe isn't something I've encountered before. That's because I made it up. I didn't make it up. I didn't make up the concept, but I did make up this value. Maybe it's just a shorthand I have for saying like, hey, it's either going to be some specific type or null or undefined. So like all that is like valid here, because depending on the way I'm doing the application, I might not have any supporting materials, and I may not want to add any at any point in time. So we're going to do something like that, right? And then we can say now, well, if we have supporting materials, make the file for it. If not, then don't. So support materials. And you want to make a directory, but I don't want to make a directory. I want to just make a file. I'm trying to remember how I did that before. I'm just going to look into create new wiki again. You said write file. Something like this, except instead of file path, I want to do working directory, and actually, what I really want to do is like extract this into a variable here. Folder equals there you go. I'm going to do it quick. refactor here because that's just a little thing that I prefer. There's probably like a longer thought here about like variable names, and it's so easy in software to like have the same name for a thing, the name of the thing, or like the path to the thing, um, the data that comes from it. Like there's all these like little overlaps, and like I just like whenever I'm using like, oh, the string that gets me to what I want, like let's use like I'll use something like name or string, and then I'll leave folder for whatever object represents the folder, and then I use like folder contents for like the data coming from the folder, just so it's like super clear. And like it's not as relevant, especially if you're like using a type system, because you can just have the hover over and like the type system will kind of tell you what it is. But just for scanning purposes, it's really nice. Like here, for all these things, we're making it clear like this is a schema. It's not just some random collection of things, and that's like important. Um, I don't know. I just think it makes like parsing code a little bit easier. So make the folder name. Cool. So now we should have a folder there, and then like, hey, if they're supporting materials, we can instead go in here and we can say, well, what I want you to do is name, and then let's do supporting materials. And then we sort of like need something to kind of jump in here and just to double check that that is in fact a string, path, the data, right? And then we can just like drop that is a string. We validate it up here. So like here we're checking like, hey, if this is real, so like if it passes this check, we know that like in here it is the actual real string. And then console log, like if something goes wrong. And is there anything else that we want to do? I guess the last thing we want to do is I have a default cover letter here, like cover letter template that I just like to throw in just to kind of like use as a guide and make like a custom template for the company. So we also want to add that cover letter template. So how would we do that? Let's see, we can do it. Const cover letter path equals. And it's actually not going to be in the folder path because it's not there yet. So here we need to sort of like be careful. And here's where we're going to need like our current working directory. So here we want to say CWD, and then we want to say templates, and then that's not it, but it's Copilot's doing its best to try and guess. And we can do a quick check, maybe. Yeah, let's do a safeguard. So we're going to say if, and we're going to say the sync cover letter path. It's like, hey, cover letter definitely is here. Then we are going to, I guess we want to copy it and paste it. But yeah, that's like the next step. We want to like copy it in the existing place and like paste it in this new folder name, which I'm probably going to rename to folder path. And this is the part like I don't want people to see like how extreme I am about like getting all these names right. But you can kind of see like the path we're going about here. And the kind of the main thing I wanted to talk about today was just like this portion, like the ability to do this, to go from very vague, potentially incorrect inputs, to go from this process.argv, just probably strings, and then using Zod to create like really concise, really specific schemas, and then being able to make a type from said schemas, and then we can use that type in the rest of our application, and like we can be sure that like what's coming out of there is exactly what we want, and that feels super good. And that's sort of like where I'm going to be going with this, and doing a bit more explorations and kind of like really tightening this up. And like the goal isn't to be needlessly verbose or like needlessly specific. The goal is to just be like, one, safe. I never want this to fail. Like at this point in my application, it shouldn't fail in a way that I haven't anticipated. Any failure I want to like be happening in this like at the first point of contact with like run scripts. Like I want failures to happen here. Like this try catch. If it makes it past this try catch, then we should be in like another safe zone. And now here we're doing more IO, and yeah, that's like another. Every time you're doing IO, that's another vector for failure. But at least I know like the data that came in through here is now invalidated, so I can constrain my focus on like making sure these operations are also in a place where like errors are appropriately handled. And yeah, it's going to be anytime I'm doing input using more Zod. Using Zod for doing these types of transformations is really good. Zod even has the ability to give you the types of both like what's coming in and what's coming out, which can be really useful if you're planning on like embedding this in something else. A lot of great applications. But yeah, that is sort of like what's happening right now. Next week, I might show you more of this if this, like sort of like the eventual version of this, or we might jump back to our like Slack validation stuff. But yeah, that's what we're going for. So at this point, I want to say to everyone who came out, thank you for coming out. Thank you for watching, as always. If you have any questions or you want to chat to me more about this stuff, you can always reach me in virtual coffee. Just shoot me a message in the Slack or Twitter or GitHub, wherever. I'm always like happy to answer questions. And yeah, if you ever want to be a guest on the stream or kind of talk about this stuff with me, if you have like ideas or insights or questions, then let me know. But with that, thank you for coming out and watching. I hope you all have a great rest of the day. And yeah, once again, TypeScript Tuesday brought to you by Virtual Coffee. See you later.